Hi, this is Owen Mason and I'll be constructing and explaining the mean proportional. So let's say we have this rectangle here, 9 by 4, and we want to convert it to a square of equal area. Now we could use the formula over here and prove it mathematically, but we're going to prove it graphically instead. So the first thing we want to do is we want to swing an arc down from D until it hits this line here, just like that. So, and then we're going to extend this line to hit that arc, and we've got a new point right here. Let's call that E. So, our next step is we want to find the midpoint between B and E. And so what we usually do is bisect the line, and then we find this point. Right there. After that, we're going to swing an arc from the center point here, let's call this O, and swing it all the way from B to E. So, although that was very quick, we have just constructed our mean proportional. If we extend our line from D up here to point F, let's call it, this is our mean proportional. This is also the first side of a square to equal area. So if we were to take this side, swing an arc down here, swing an arc over here, and join them all up, we would get a square of exactly equal area to the rectangle. So, why does this work? If we were to draw a triangle by joining point B to point F and point F to point E, so what we have here is we have a triangle of height of height A to F and length BF and length FE. So this angle right here is a 90-degree angle. How do we know this? Because this angle is sitting in a semicircle, and any triangle that rests on a semicircle and has a point touching is a right angle. So if we were to assume that this corner here was 30 degrees and this corner here was 60 degrees, for example, what we can do is we can figure out that we have two right angles right here, and so that means that the opposite side up here will equal 60 and 30 respectively. Thus proving this right here is a right angle. So what does this have to do with the mean proportion? If I were to take our triangles here separately and put them down here next to each other, what we would see is that our triangles are congruent. So what we'd have is we'd have FAB, and we would also have AEF. So we have our angle down here being 30, that would be equal. We would have our angle up here, 60, that would be equal. And our angles down here, 90, would be equal. But the lengths of the sides would not be the same. But what is in common is that the height, I did that wrong, the height is the same, and the height is the mean proportional. And thus we proved the mean proportional through congruent triangles.